Hello again. Now we move on to Chapter 3, Mechanical Properties and Testing. At the first start, I give you the idea of materials concept, either on engineering applications or materials innovation. And on Chapter 2, we go a little bit deeper onto crystal structures of metals. That will give you the ideas how the materials behave relate to how the metal can be deformed. And now in Chapter 3, we step back a little bit and look for the general area in terms of mechanical properties and testing. And if you think about metal is normally classified as structural materials. And to that, the first thing you may think of is mechanical properties. As an engineer, you may think of how safe to use it, how strong the metal is, how hard the metal is. And therefore, mechanical properties are one of the key properties when you want to use it. First of all, I would like to give you the ideas how important it is. And that would be in the first topic, the significance of mechanical properties for engineering applications. Then topic 3.2, I will get along on concept of stress and strain, on the definition of both stress and strain. And the stress and strain can be demonstrated on graphical demonstration as we know as the flow curve, and what kind of parameters that we normally use for stress and strain. And finally, topic 3.3 is the big part of this chapter on the standard test methods and interpretation. Actually, there are a broad range of standard test methods for mechanical testing, but I would like you to focus on just 5 standard test methods, which are hardness, tensile, creep, impact, and fatigue, which are quite the basic ones for most engineers that's to experience when you're working after graduation. For each test, I will explain the principle behind it and how to do the test, obtain the standard parameters. And finally, we also have to interpret the test data in order to use for the selection of materials. By the end of this chapter, the learning outcomes include, first, to relate mechanical properties of metals and its engineering applications. For example, if you think about the suspension bridge, what kind of force that's most related to its application? What kind of properties that is the most important? Of course, that is strength of materials. You may think of the strength of the steel cable that's used for that application. And how do we know that the steel is strong enough? We have to read on the specification of the materials that the engineer used for making the steel cables. And that specification comes from the test report that the engineer have done the standard test on that cable. And that's how you relate the mechanical properties and standard test to its engineering applications. That's the first learning outcome. Second, to calculate stress-strain parameters obtained from mechanical testing. How can you calculate that with the correct unit? And the third one, to interpret the test parameters for the selection of metals in relation to service condition. That's the main goal.